All right, so we are looking at the beginning of Chapter 8. Again, this is going to be a really quick chapter probably, and we'll get as far as we can before we have to quit for the semester. So 8.1 is Intro to Polynomials, and so we're going to be talking about polynomials, and we've got our mission here as well. I can classify a polynomial by its degree and number of terms, and I can add or subtract polynomials. So I want to start out with an example polynomial, and then we're going to try to figure out where it needs to go in this little table that I've created here. I know this is kind of rough, but I'm sure there's a better way to do this. I just don't know what it is right now. So this is the way we're going to do it for now. And I'm just going to go ahead and write an example polynomial here real quick. X plus 2x squared plus 3, okay? And a couple of things I want you to note about this particular polynomial. Again, you notice I've got x here first and then plus 2x squared plus 3. So when we're talking about classifying, it's like if I was trying to describe this particular polynomial to somebody, how would I describe it to them? Well, you can describe it in terms of its degree as well as its number of terms. So we're going to look at both of those right now. One of the first things I want to explain to you is something called standard form, okay? So in standard form of a polynomial, the way that you would write this is you would start with your highest exponent first, and then it goes down in descending order. So you notice I've got 2x squared here. I've also got an x here that's being raised to the first power. And this may be a little bit odd, but I want to present to you that there's also another x on this screen other than these two here. And you're thinking, Mr. Hamilton, you've lost your mind. Well, I could also say that there is an x to the 0 power right here, because if x, anything to the 0 power is 1, so that would just be 3 times 1, which is still just 3. So it doesn't really change the answer, right? So what I want you to see if I write this in standard form is the 2x squared would be written first, okay? And there's a reason for this. There's a reason that this is important. The next thing is I'm going to have an x right here, okay? So I'm going to add the x. I'm going to just put it in the second spot because this is raised to the first power again. And my next term in descending order would be the 3. Now, I don't have to put the x to the 0. I just did that so that you could kind of understand what's happening. And yes, my phone's ringing. It always rings, but it's okay. We'll just keep going anyway. So here is this particular, this is equivalent to this that we have here, but it's just written in standard form. And the reason that's important is because when we talk about degree, it is always the highest exponent that the polynomial has, okay? So if you notice, the highest exponent I have is a 2, so this would be a second degree polynomial. So I'm going to go ahead and write that right here, and you understand why I'm doing it there in just a few minutes. So this particular polynomial that we just discovered is a second degree polynomial. So I'm going to go ahead and write that as an example here, 2x squared plus x plus 3, okay? So the other thing we need to talk about is the name of that particular polynomial. And this is kind of an odd one. It's maybe a little bit harder to understand why it is, but just know that when it is second degree, it is a quadratic, okay? It is a quadratic. So the name of this polynomial is a quadratic simply because of this index right here, because of the highest degree it has is an index of 2, okay? So let's look at another example here real quick. We'll say 3x plus 2, okay? So again, I have an exponent of 1 here. There's really like a 0 here, right? But we kind of know that we don't have to write that every single time. But we know that this has a higher order than this, okay? And this, as a matter of fact, is already written in standard form. It's got the highest exponent first and then the next exponent next, okay? So I can confidently say that the degree of this polynomial is indeed a 1, okay? And this particular polynomial, okay, has a degree of 1, and there is a very specific name for this, okay? If we were to pull up Desmos, and for the sake of time we won't, but if you pull up Desmos and you just graph this, 3x plus 2, it will actually make a linear equation, okay? So linear equation kind of looks like this. It's just a straight line, so that's why it would be called linear, because the word line is literally in it, okay? So I kind of jumped ahead of myself a little bit, so we'll backtrack just a little. The other thing we need to talk about in this one here, and I'm going to go back to this one real quick, and then we'll be able to pick this one up as well, is how many terms do I have here? Okay, so you notice the terms are everything except the addition, subtraction, the operation symbols, okay? So you notice, and I'll use this one up here as an example. I have one term here, I have another term here, and I have another one here. So this actually has 3 terms, okay? So this is yet another way I could classify it. Again, if I was trying to tell somebody what kind of polynomial I was working on, I could tell them that I'm working on a quadratic polynomial, but I also need to tell them how many terms it has. Well, this one has 3 terms. So this one really is kind of common sense. If you think about a 3-wheeled bicycle, that would be called a tricycle, okay? Maybe when you were kids, you had a tricycle. And so this is a trinomial, okay? A trinomial. So anything that has 3 terms would be a trinomial. Well, let's think about this with this one. How many terms does this one have? Well, it has only 2 terms, okay? So this one, in fact, would have 2 terms, which, again, how many wheels are on a bicycle? Well, bicycle has 2 wheels. So it is a binomial, okay? So again, if I were describing 3x plus 2, I could say that it is a linear binomial. If I'm describing 2x squared plus x plus 3, I could say that it is a quadratic trinomial. Okay, so you kind of get the idea. Now, what if I just had the number 6 right here? What degree is just the number 6? Well, the degree, as a matter of fact, again, remember if I had over here where I had the number 3 by itself, I went ahead and put x to the 0, which really just canceled it out and left me with the 3. So the degree here is actually 0, okay? The thing is, what do we call that? Well, think about this for just a second. If I just have a 6 equals 6 all the time, okay? But if I had 6y, then that y could literally be anything. In other words, it could be 6 times -1, which would equal -6. It could be 6 times 2, maybe y is 2, and it could equal 12. So it could be different if it had a variable with it, but because it doesn't have a variable with it, this remains true or constant all the time. So when it's just one letter by itself without a variable, that is a constant. Let's think about how many terms we have here. Well, over here we call this a term, right? And so we have to say that this is a term as well. It's at least one term, right? Which means that this would be called a monomial, okay? So again, just for the sake of time, we're going to kind of speed this up just a little bit because I've got some other problems and things I need to show you as well. So let's say we had something x to the 4th plus 3x plus 2. Again, my highest degree, this is in standard form. So you need to make sure it's in standard form always before you ever start. But notice that my highest index is a 4. So that means my degree here is in fact a 4. So I'm going to do x to the 4th plus 3x plus 2. And here I want you to think about how many, if you take a gallon and you split it into 4 parts, what 4 parts goes into a gallon? Or if you're thinking about a dollar, those 4 individual units that go into making up a dollar, well, those are quarters. It takes 4 quarts to make a gallon. So when we're talking about 4 of anything, we kind of have this prefix quart. So this is quartic. Quartic describes any polynomial that has a degree of 4, okay? And again, how many terms do we have here? We have 3. So this would be a trinomial. Okay, last but certainly not least, what if we had x squared plus 3x to the 3rd plus 2 plus x? Well, first of all, I need to get this in standard form. As of right now, it's not in standard form. I've got this raised to the 2nd, this raised to the 3rd. This is not raised to anything at all. This is raised to the 1st. So I need to get it in descending order before I decide what degree it is, because it's easier just to look at this first term and think, well, it's quadratic. Well, in all actuality, that's not the highest index that we have, okay? So let's rewrite this as 3x to the 3rd. That would be my first one. My second one would be x squared, because remember, I want to put these in descending order. My next one would be x, and my next one would be 2, okay? So you notice my index here, my highest degree right here is a 3. So this is an example of a degree 3. So 3x to the third plus x squared plus x plus 2. And again, what would 3 dimensions really? If we got 3 dimensions, what do we think about? Well, we think about something like a cube, right? Because it has 3 dimensions. Well, as a matter of fact, when you're talking about something of a degree of 3, it is in fact cubic, okay? So now let's think about how many terms we've got here. We actually had 1, 2, 3, 4 terms. And so this, I guess math people kind of got bored and they thought, well, I'm tired of naming these. So when they got to 4 and beyond, they just simply say a polynomial with 4 terms. So if that had 5 terms, you just say polynomial with 5 terms. So I want you to kind of take note of this, because this will come in handy when you get ready to take your practice, okay? So we have kind of covered this part where I can classify a polynomial by its degree and number of terms. You're going to have about 6 questions on your practice that are going to be related to that. So this right here is really going to be helpful if you want to pause the video and kind of jot that little table down, and it may be very helpful for you, okay, before we move on to this next part, which is adding and subtracting polynomials, okay? So I'm going to go ahead and clear my screen. Get this guy out of the way for just a second, maybe not. Okay, you don't want to move now. So we'll hide him for now. All right, so I'm going to give you 2 different problems. We'll just call this problem number 1. And so we have negative 9x squared plus 10x plus 3 plus 6x squared minus 7x plus 5. Okay, so we're going to work on this problem. And again, we're asked to add these 2 sets of trinomials. All right, now we know the term for that because we have 3 terms here. They're separated by parentheses. What I want you to notice is that really these set of parentheses, they don't really take away or add to the problem. And here's what I mean by that. In other words, you would have a 1 right here that would be multiplied times all of this that's inside of here. So if I multiply all of this that's inside of here by a positive 1, is it going to change my answer? And really the answer is it's not going to change my answer at all, because 1 times 6x squared is still 6x squared. 1 times negative 7x is still negative 7x. So that's not really going to change my problem at all. In this case, what I want to do is I'm going to go ahead and get rid of the parentheses, okay? So I'm just going to rewrite my problem. And I'm just going to leave out the parentheses. Obviously, these signs go with these terms, so they have to stay the same. But now I have this big long thing that I need to take care of, okay? So now I really need to understand like terms, okay? Like terms have to have the same exponential value. So in other words, if I had 4x squared plus x, I cannot add these terms together because they are not raised to the same power, okay? So in this case, I can't, these are not like terms I can't add. But if this had been x squared, then I can add those terms together. So let's take a look at this, and let's go ahead and circle our like terms. I'm going to use my blue marker. You notice I have a negative 9x squared. Do I have anything else over here that has an x squared term in it? Well, as a matter of fact, I do. It's right here. So I can go ahead and do this operation with those 2 terms now. So I have negative 9x squared plus 6x squared. So negative 9 plus 6. Let's think about what that is. If I had negative 9 and I added 6 to it, I'm actually going to have negative 3. And the x squared just kind of comes along for the ride, okay? That literally could be any variable. As long as it's the same, they are alike, then I can add them or subtract them. So this would be for that term. Now let's take our red marker and let's circle all the ones that have only an x to the first. So we look through our list, and you notice we've got another one right here that also is raised to the first power. So now I can combine those as like terms. So I have a positive 10x minus a 7x, which gives me a positive 3x. And so last but certainly not least, I am left with this positive 3 and a positive 5. And if I add those two values together, positive 3 plus positive 5, I'm going to get a positive 8. And so this would actually be my answer right here that I would end up with, okay? Again, I took all of these terms and I just figured out which ones was the combined, or the ones I could combine because they're like terms, and I added them together. So this would be our answer. So now let's look at another one that we're going to be doing subtraction on. So if I had negative 3x squared minus 4x plus 5 minus 6x squared plus 5x minus 2. In this case, if I look at this as being a negative 1, then it is definitely going to change my answers, and here's why. If I take 4 times negative 1, that is going to equal a negative 4. So I end up with a different answer than what I started with, okay? So in this case, it does really matter. These parentheses do matter. Now, this first set doesn't matter because there's not any like terms I can do anything with on the inside of here. But when I'm subtracting these from this, then it does indeed matter. So here's what we need to do with this is we need to rewrite this just like we did up here. We're going to have negative 3x squared minus 4x plus 5. But now I'm going to be subtracting a 6x. Well, think about how you write that. Subtract 6x squared, okay? So notice what happens. Whatever signs I have over here, it's going to change when I subtract it. So in other words, when I subtract a 5x, notice my signs change from a positive 5x to a negative 5x. So what do we think is going to happen here with the negative 2? My signs changed on this one. My signs changed on that one. Guess what? When I multiply or divide by negative 1, it's going to change my sign. So instead of a negative 2, it's going to be a positive 2. From here, this becomes exactly like the problem we did a few minutes ago. So we'll start in the same order. We'll use our blue pen, and we're going to circle the x squared term, and I'm going to circle any other x squared term that I find. And now I'm going to go ahead and do the operation. So negative 3x squared minus 6x squared is going to be negative 9x squared. All right, and do the same thing again with my red color. I'm looking for anything that is just raised to the first power. So negative 4x minus 5x is negative 9x. And last but certainly not least, I have my constants, positive 5 and positive 2. 5 plus 2 equals positive 7. So again, this would be my answer for number 2. And actually, these two problems are actually problems that you're going to have on your practice. So I fully expect that you will get at least these two right. Now, they're not number 1 and number 2, but they are on your particular practice. And so, again, hopefully this has been helpful and you've learned something. If you have any questions or concerns, obviously you can reach out to either me or Miss Wheeler, and we'll be glad to try to help you with them. Thanks.